Okay, hello everyone. Welcome to the second Lightning Talk session. I'm going to be MC for this in the next session. Let me just mention a few quick ground rules. They're Lightning Talks, so we want to stick to schedule. We have 10 minutes for each speaker. I've asked each speaker to try to leave time for a few questions. Some may have more, some may have less, but we're going to stick to the 10-minute slots. If you run out of time, you have questions, you can always grab them in the hall and talk to them offline. I'm going to ask speakers actually to introduce themselves. That'll save time and less likelihood I'll mismangle their names. So without further ado, sorry, we have 1 minute in case folks actually get here on time. Let's not be early. Oh, and by the way, we don't have time or enough microphones to throw microphones to folks. So if you have questions, just speak aloud, and the speakers will repeat your questions, hopefully. That's pretty much it. Okay. A minute's a long time here, actually. All right, why don't we get started?
Let's see. Does this work? Okay. I'm not on the clock yet. Oh, I'm on the clock. Okay. So I'm Nathan. I work on Bazel. I work on Bazel's Incrementality Engine. And this talk is going to be how Bazel handles Symlinks correctly incrementally. And this is a lightning talk. I'm not going to have time to motivate everything in detail, so I'm going to have to breeze through stuff. And I wasn't planning on having time for questions, but we'll see if I can skip some content. All right. So first off, a very quick review of Symlinks. These are some commonly used bash commands to do stuff with Symlinks. The first one's ln. The -s option means make a symlink. And so ln-s ba means have A point to B. So create a new symlink, A, that references B. And symlinks can be relative or absolute. For simplicity in this talk, we're just going to do relative symlinks. Use ln to make a symlink, use unlink to destroy a symlink. You can use stat to get information about any path, including a symlink. By default, stat follows symlinks. More on that in a moment. Stat-L does not follow symlinks. And this is analogous. Stat-L under the covers calls the libc function lstat, which means not following symlinks. And it's kind of confusing how like the L, the -L means follow symlinks, and the lstat means don't follow symlinks. And then the real path bash command gives you the real path of a path, accounting for all symlinks. So that is all symlink chains, all ancestor symlink chains, blah, blah, blah. We'll see that in a minute. Here's some examples. So starting with the top left, I make two directories B and C. I make a file F under each of them. So there's B/F and C/F. And then I get the real path of B/F. And I'm not doing anything fancy with symlinks. So as expected, the real path of B/F is B/F. And then stat, just to confirm that B is a directory and B/F is a file. Okay, so that's boring. The middle example on the left, I have a pointer. Okay, so we create a symlink, A points to B, and then stat says, yep, it's a symlink. And B from the previous example was a directory, so stat following symlinks says that A is a directory, but and then if I can stat the path A/F, and that's a file because remember B/F is a file up here. And the real path of A/F is B/F because everything works as expected. And then the example on the bottom left, I can unlink A, so link A doesn't exist, make A point to C, and the real path of A/F is now C/F. And then up in the top right, I can do what's called make a dangling link. So first I'll unlink A, I'll make A a link to nope, and then I'll try to stat the path A/F. It doesn't exist. And then down here's a more complicated example where I can do things with layers of directory ancestor symlinks. More on that in a moment. So the real question is this talk relevant, or am I just like talking for fun? Or do symlinks maybe matter to Bazel? So in this example, pretty simple Bazel example. So I have a bash one-liner to print out all the files in my workspace. So I got, let's see, blah, blah, blah. Sorry, I got a build file. It loads a Starlark file, a BZL file, and calls a macro foo. Foo, when called, instantiates a sh binary target that has our source file. That source file is just runs the bin/true command. So if I do Bazel build foo::foo, everything works as expected. And the question is, could symlinks possibly matter? Well, for starters, the build file itself could be a symlink. The BZL file itself could be a symlink. The .sh source file could be a symlink. And actually, the foo directory could be a symlink. So everything is hard, maybe. OK, so actually, is everything easy? So for starters, lots of command line tools just follow symlinks transparently. For example, cat. So if I, where's my pointer? If I make a text file b.txt and make a.txt a symlink to b.txt, and I just cat a.txt, it works. Like, right? Everyone's done this before. What's happening under the covers? If we strace the cat command, the dash capital P means only print out stuff that's consuming this path. We see that cat under the covers is using the system called openat, which transparently follows symlinks. So that's the reason cat works as expected. And a bunch of things do this too, like JavaC and various other tools. Basically, almost every tool you use probably follows symlinks transparently. So the question is, could Bazel do that? And so consider this hypothetical example. So we do some build. We make arbitrary file system operations. Then we do another build. Well, what if those arbitrary file system operations include introducing symlinks, changing targets to symlinks, introducing symlink cycles or something like this? We claim to be both fast and correct. And it's not obvious how to do that in the presence of arbitrary symlink stuff. Because either you don't handle symlinks, and then you're just wrong incrementally, or on every incremental build, you fully resolve all the symlinks, and then you're not fast. OK, so fine. Let's just do everything. OK, so we have an incrementality engine where we express Bazel's business logic in terms of evaluation of mathematical functions. So if we can think of how to do symlink stuff using mathematical functions, everything works for free. So let's implement the equivalent of the bash realpath command ourselves. So if we have a helper function, ls, which stands for lstat, that tells us the stat information not following symlinks, our goal is to have a function rp standing for realpath that computes the realpath of a path. And so here's this, I'm not going to have time to go over this. Here's just the obvious implementation where you basically recursively get the realpath of the parent directory, and then you get the lstat result of the path in question. And if it's a symlink, you append those paths, and then you recursively resolve that in case that pointed to another directory or something. OK, so this works. Here's an example. I'm not going to have time to go through this, but basically we have some symlink chain, and it just works. OK, are we done? No. Because here's the trivial counterexample. We have a circular symlink, a symlink cycle of size 1. A points to A, and our function recurses forever. This is actually necessarily a bad thing, but it means some features of Bazel don't work out of the box. So we want to solve this explicitly. So symlink cycles, blah, blah, blah. It turns out that the kernel handles this automatically. And there's a hard-coded limit on the number of symlinks it follows. This is just a fun aside. OK, there's also something called Symlink infinite expansions. This is relevant if you're doing a recursive directory traversal. So there's two flavors. The flavor on the top is when a descendant is a symlink to one of its ancestors. And the flavor on the bottom is when an ancestor is a symlink to one of its descendants. So naively, if you don't think about this and you're doing a recursive directory traversal, you're going to loop forever. The find bash command does handle this correctly, as you can see by these error messages. So we have to think of both of these things. And skipping a lot of details here, the trick is to think of the logical chain of operations when resolving symlinks. So in this example, we have some chain ending in b/c. And b/c was already in our logical chain of operations, and so that's bad. So this is the algorithm that Bazel uses. I'm not going to have time to go through this, but the key thing I want to focus on is the detecting badness part. So the general algorithm is a pair of co-recursive functions for resolving a path given the full resolution of its parent path, and resolving a symlink given the partial resolution of the path so far. But the key thing is we keep around knowledge of the logical chain of operations we've done so far. And so this is all in the Bazel source code. Basically, I'm replacing it. Here's the interesting part. Okay. So if we are in the act of resolving a path and we already have some chain of paths we consider, we want to determine whether the path we're looking at right now is bad. And by bad, I mean it's either a Symlinks cycle or it's one of those two expansion cases I discussed earlier. And so this is the pseudocode for that. Okay. So if we're considering, if we're about to consider path, we've already considered this chain of paths, and that path is in the chain, okay, cycle. If the path is a descendant of something in the chain, that's one of the infinite expansion cases. And if it's an ancestor, it's in the other case. And so we can actually do this efficiently if we store the chain both as like a linked list and also a binary search tree, because then we can do these two cases in logarithmic time. And so Bazel does this. And if you're curious, you can look at these two source files. And because of this, we get incremental correctness completely for free and performance for free. So we do minimal work on incremental builds a moment at a time. And so here's a crazy example where we have like lots of layers of directory symlinks. I haven't seen any other tool that gets this correct, but Bazel does, and we have a nice informative error message about what's going on. All right, thank you for your time.